Alright, we're back in the racetrack. In the previous video we spent some time preparing the card to accept keyboard controls, and now we're finally ready to implement the movement logic. But before we do that, I'd like to apply a small suggestion that you guys have made in the comments, and it simplifies the assignment of the geometry object of the track component. The easiest way of assigning a geometry that was created by GLTF loader is to simply feed it to the geometry property of the mesh instead of having to use the primitive construct as I was doing here. And I have no idea how I missed that. I guess I'm just getting older. Having that said, we can start to develop the controls of the car. I've created a new script that is just exporting a small hook, which at the moment does nothing, but the idea is to create a new object called controls that will contain a bunch of booleans that tells us which key is currently being pressed. The car will move around with WASD, and R will be used to reset its position in space and its velocity. To register keystrokes, we need to add two new event listeners, and I'm doing that inside a use effect where I'm creating these two functions that will respectively listen for key down and key up events. That's obviously not enough to just listen to the events, we also have to modify the controls object according to the key that originated each event. And in case you're not familiar with this syntax, what I'm essentially doing here is to take the previous value of the controls object and returning a new object here with a copy of the content of the previous controls plus an updated property that is the lowercase name of the key that was pressed, and the value will be set to true because this is a key down event. And all of that was just to say that, for example, if we press the W key on the keyboard, we have to update the controls and set W to true. Finally, it's time to write the logic that uses the controls object to move the car. Here, I'm checking if the W key is pressed, and if that's the case, I'm using the vehicleApi to apply a force to one of the wheels of the car. The second argument of this function takes the index of the wheel that should apply the force, and for our vehicle, index number 2 and number 3 are the indexes of the front wheels of the car. In short, if we're pressing W, we're going to move forward. If we're pressing S, then we're going to apply a force in the opposite direction, thus moving backward. And if we're not pressing neither W or S, we're resetting the force back to 0. Inside the car component, now I'm importing the controls. Here's the magic in action. We can move forward with W and backward with S. And what about steering left and right? The process is similar to what we've already done for the engine force. There's a method in the vehicleApi to set the steering value. When pressing A, the front wheels will steer to the left. A positive value means that we're steering to the left. And the back wheels that have index 0 and 1 will slightly steer to the right to increase a bit the steering power of the entire vehicle. The values are reversed when pressing the D key because we want to steer right, and if neither was pressed, then we are setting the steering value of each wheel back to 0. And look, now I can move left and right. One of the remaining issues though is that our car can still pass through all of the objects overseen because we haven't set the colliders yet for each of these objects, and that's what we're going to do next. To simplify the process, I've made a new component that it's creating a new physics entity. In this case, it's a box that I'm setting to static because it will always remain fixed in the same place. Then to help us visualize the box that we've made in the physics world, I'm creating a new Three.js mesh that has the same position and scale arguments of the box that we've just made here. Okay, let's test this new collider script inside the track component, and I'm setting here the position and the scale of one of the trees, and we'll see if it works. And it seems like it's working. Now the car is colliding with one of the trees, or rather the simplification that we've made of the tree, with a simple box. We'll need a bunch of these colliders to cover all the objects of the scene. You can just copy paste this block from the repo, and if all went well, the car should now stop every time we try to crash it in one of the trees or the other elements of the scene. Now that we've proved that the colliders are working, we're going to set the debug variable back to false, and we'll move to the next piece of the puzzle, which is the ramp. So far we've used simple geometries to model our physics entities, like with use box and use ground, but the ramp will be created from a 3D mesh, which we first have to download, and it's in the same folder in the repo where you can find the other models. As always, I'll share the link in the description. And once we have the model, we'll download it with use loader and then pick the geometry of the mesh. From the geometry, we'll need the vertices of each triangle, and we'll give these vertices to the useTreeMesh hook, which will create a new physics object that has the same shape of the mesh that we've downloaded. And if you're wondering what the indices array is, very often on a mesh, some vertices are repeated a lot of times. So for example, in this case, the vertex at the center was repeated 6 times by these 6 triangles, and it's not necessary to store the data of each vertex multiple times, because very often it's not just the position but also the normal of the vertex, the UVs and other stuff. So what you do instead is save an index to this vertex and then use it each time you want to create a triangle with that vertex. Lastly, I wanted to mention that when possible, you should probably avoid using useTreeMesh, because creating an entity from a mesh can impact the performance of the engine, since meshes very often have a lot of triangles, and simulating collisions with all of them can be very expensive. In this case, I'm not too worried because I know that the mesh that I'm using is simple enough, but in general, if you can decompose your entities into simpler shapes like we did with the vehicle being a simple box, that should in theory improve the performance of the engine. Now we can import the ramp inside the track component, and we reach the finish line again. Our vehicle can now move around and interact with the other entities of the scene, including the ramp, which was created from a 3D mesh. Hope you guys have enjoyed this part of the series. We're really close to completion, so thank you for watching and see you on the next one.